Hello everyone, welcome to my channel Kick the Problem. I'm your one and only Shivam back again with a new video on searching and sorting. Today we are going to solve a problem in which we are going to find smallest positive missing number. So guys, in this problem, one thing you should consider that your code should not exceed the time complexity of order of n and space complexity of order of 1. So guys, if you are new to our channel, please do like and subscribe our channel and press the bell icon so that you get notified whenever we upload our new video. So guys, let's see the solution of this problem. So guys, here you will be given an array and you have to return the smallest positive missing number. So guys, I have taken 3 examples. You can see in first example the elements are like 3, 4, 7 and 1. If you consider for a while, the elements are in sorted order, so you will check from left side. At the starting there will be 1, and then after 3, then 4, then 7, and the starting from left side there is 1. After that the number at first which is missing over there is 2, so we have to return first smallest positive missing number, so it is written 2 over here, hence the output is 2. In the same way, if we see in this array, the elements 1 to 5 all are in sorted order, we no need to do any sorting, but there is no any element missing from 1 to 5. In this case, what we are going to do, we are going to return the element n plus 1. Like this element, this array is of size 5, so we are going to not return 5, we are going to return 5 plus 1. That is our output. And one more case we can arise, like if it contain negative element, so we are going to ignore that one, and then after we are going to see remaining. If we leave -1 and for a while we consider the array sorted, then what we'll get 0 over here, then we'll get 1, and then after we'll get 3. So again 2 will be missing over there. That is our smallest positive number, so we have written 2. That is our output. So guys, here I have explained you about 2 approach. First one is naive approach. So in this approach, what I have done is simply I will use a built-in function, that is arrays.sort, and will pass argument as that is our array, and then after sorting we'll just run a for loop, and from left side we'll check that the element that is missing over here, like here 2 was missing. From left side if you check, 1 is first over there, then after 2, and we just can put one condition over there, the element should not be negative, because we are going to return only positive. So start traversing from left side the elements that are positive and missing, so we are going to return that. So time complexity of this approach is order of n log n, and space complexity is order of 1. So guys, you might ask that why you are explaining so much easy question. Yes, this question is very much easy. It is easy if we are using order of n log n, but in question it is asked to code in get the solution in order of n and without any extra space, that is space complexity should be order of 1. In that case we are going to get difficulty, so that I am going to explain in our second approach, that is our naive approach. So what I have done is I have taken one example, same example. First example, you can see array consists of element 3, 4, 7 and 1, and you know its output should be 2. So what I will do over here is, like here this is our array elements 3, 4, 7 and 1. Normally array indexing is done starting from 0, but I have done 1, 2, 3, 4, but it's not a problem. If you are I'm doing 1, 2, 3, 4, you can just increase by n plus 1, that's same I plus 1. So initially our pointer, while running a for loop, it will start from left side, like first element it will point to this element 3. So what you have to do is you have to check this element, there is 3 over here, so you have to go to the index 3 and you have to replace this 2 elements. This 7 will come over here and 3 will come to third index. So you can see over here 7 came here and 3 came here, remaining all the elements are same. Now even now our pointer is over here, Now we'll check after exchanging. I will check 7. This 7 is like size of our array is only 4, but 7 is very big element, so we cannot exchange with anything, we cannot replace. So after that our pointer will come over here, we'll increase our pointer and our pointer will come to second element. Now here is 4, so we'll go to fourth index and we'll exchange these two elements. So guys, you can see now 1 came over here and this 4 went to this fourth index. So after that even now our indexing will remain over here. Now I will check 1 is in our array index or not. Yes, 1 is over here, so we have to exchange these two elements. So 1 came over here, 7 came over here. Now again our indexing is over this element only. Now even now 7 is not in this array, that index, it's very big number, so we are not going to exchange anything. After that in pointer will increase and indexing will come to our third element. It will check that it is already in 3, so no need to exchange with anything. Again it will come to 4, and here is also 4 already over here, so no need to change anything. So after running this for loop we'll get our array in this order. Now what I will do is, again I will use a for loop and traverse this array. Now at that index where the at first index there is 1, at second index there is, you can see, 7, at third index there is 3, at fourth index there is 4. Only this element is not at its original index. So starting from left side, the first element which we will get that is not at that own index current position, so we will return that as our smallest positive missing number. So our smallest positive missing number will be 2, what we can see over here, 2. So for that I have written code over here. The code is clearly simple. Our code starts from here, like this is our main function. So what I have done is, in first for loop, first I have initialized one variable, current position, like I have said, like here I have explained you for 1 2 3 4, but in actually the indexes are 0 1 2 3. So for that current position you have to initialize an array of I minus 1, because indexes are from 0 1 2 3 4 in the same way. That's why I have written. Now you'll run a for loop, like the smallest positive number whatever you are going to get, that lies between 1 to that n size of that array. Like you can see over here, here are 4 elements, so you are getting 2, that lies in 1 to 4. Or you might, if you are not getting 1 to 4, you can see in this case, then you might get n plus 1. Out of that range you are not going to get, neither you are going to get negative number nor you are going to get n plus 2. You are only going to get 1 to n. If you are not going to get in this array, then you can return directly n plus 1. In here also you can see the size of this array is 1 2 3 4 5, and you are getting 2, so it is also lies between 1 to n. So what I have done is, I am running a for loop first, then after I have initialized one variable current position, and we are restoring that element to our current position. After that I am running a while loop. This while loop run till our array lies between like 1 to n, I have said na. So greater than 0, array of I should be greater than 0, and array of I should be less than size, that is n. Here it is given as size is given, n is given as size, and our array of I should also not be at its current position. Like you can see, 3 is not at its current position, its correct position is this. So that's why if we get our correct position, so we'll stop running with this while loop. So what I have done is, I have used a swap function for I have done swapping. So I have simply written here swap function. This is normal swap function. In this I have passed argument I, array and current position, and after that after swapping these two elements, what I have done is current position again I have written array of I minus 1, because like you can see over here, um, in this case after swapping this 4 and 1, still 1 is remain over here. Like in some case we are going to get like this also. Second time also we have to do swapping. Our indexing is over here, we have swapped this two. Now even now we cannot increase our pointer, and we have to swap another two element even remaining at this index. So our new current position will become array of I minus 1. So I have updated this, and again if we are not going to get array of I equals to array of current position, like again we are going to get 1, the number that we can exchange. So again we are going to do swapping. So after running this for loop, our array will become something like in this condition, we'll get in this way. After that simply we are running a for loop, and if ith of 1 not equals to array of I, so we are going to return I plus 1, because here I have written 2. That means in indexing case it start from 0, so here it will become 0, here it will become 1. So but will get your answer as 2, so that's why I plus 1. If I plus 1 is not equals to array of I, so at that case I will return array of I plus 1. And if we are not going to get this condition, what I said, we have to return. In this case you can see, if we after traversing this element we are not going to get our smallest positive integer, so what we have to return n plus 1. That n is over here as size, so I have written size plus 1. So guys, this is simple code. The time complexity of this approach is order of n, because we are just using for loops. You can see one for loop is over here and another for loop is over here, and this is simply swap function. And space complexity is order of 1, because we are not going to use any extra space. So guys, this is our code that I have explained you. Let's compile and run it. You can see here it is running for first test case containing element 1 to 5, and its output is 6. Same thing we have got. Let's submit our code. You can see our code is successfully submitted. So guys, if you like this video, please do like and subscribe our channel and press the bell icon. In future I'll be uploading many these kinds of video related to DSA and algo. Till then, keep enjoying and keep watching Kick the Problem. Bye bye.